In this video, we are going to wrap up our lecture on integrals resulting in inverse trig functions by going backwards. We're going to talk about a uSub using inverse trig functions. And so this may feel a little bit like review, and that's okay. So this is from Cal 1. If you remember the derivatives of your inverse trig functions, arc sine resulted in 1 over the square root of 1 minus x squared, and we had arc cosine being just the negative of that. And then the derivative of arctan is 1 over 1 plus x squared. And these should look so familiar now that you've seen part 1 and part 2 of this series where we talk about integrating things of this form. So we just saw that the integral of 1 over the square root of 1 minus x squared was arc sine. We did work there. So let's see if we can kind of combine both of these ideas together. So we're going to use uSub to solve the integral negative arc cosine of 6y over the square root of 1 minus 36y squared with respect to y. When you look at this, you're probably thinking, okay, this has that feeling of arc sine, arc cosine, but I have this thing in the numerator that is arc cosine, and now, this is like not as clear. But when we see things and their derivatives together, that's uSub. So we're going to let u equal arc cosine of 6y. Then when we differentiate with respect to y, we're going to end up with exactly what we want, negative 1 over the square root of 1 minus 6y squared. Well, that's 36y squared, right? Okay, don't forget your chain rule here. So we've got to multiply by that 6dy. So up to the constant 6, we're looking very good. So I like to sort my du very well before I go back. So I'm going to go ahead and write 1/6 du equals negative dy over the square root of 1 minus 36y squared. And for me, now I've got the signs in the right place. My 6 is kind of tucked out of the way. It's kept with the du. And I can very simply perform my uSub 1/6 times the integral of u du. It's very straightforward. So I'll have 1/6 u squared plus c, and then I'll go back where u was arc cosine of 6y. So my final answer here is 1/6 times arc cosine of 6y quantity squared plus c. In our last example of this video, we are going to have limits of integration. And I am a big fan of readjusting or reevaluating my limits of integration when I do the uSub. You do have the option to do your uSub, don't mess with your limits of integration, carry out your work, and then when you come back to X, then evaluate. I like to just change X to U and stay in U. And that would require me to reevaluate my limits of integration and readjust them. So we'll do that here, but it's totally up to you. So here's my friendly reminder about the derivative of arc sine. It looks good. I've got a derivative and its function together as my integrand. So I'm going to let u equal arc sine of x. Then du will be just dx over square root 1 minus x squared. And this is an extremely straightforward u substitution. But I want to evaluate 0 and 1/2. Those are in terms of x, and I want to see what they are in terms of u. So u of 0 would be arc sine of 0. So my lower limit of integration is 0. And so since u is arc sine, I need to say, well, what's arc sine of 0 then? And what that really is asking you is it's saying, hey, sine of what is 0? And you probably know very well that sine of 0 is 0. So that's going to be there. No change, not that interesting. But when x is 1/2, what is u? U of 1/2 is arc sine of 1/2. So that's asking the question, sine of what is 1/2? And you may know it as pi sixth. You may not. And if you are like, how am I supposed to memorize that? I'm going to do it at the end of the example. So if you're good on arc sine of 1/2 being pi sixth, then like once we get to plus c, you can go ahead and shut down. But if you'd like to see the how we got that, I'll keep going. All right, so I'm going to have 0 to pi 6 as my new limits of integration, and then my u sub is just 2u du. So nothing happened with the 2, it just remains, and then it really is just u du. So hey, look, u squared from 0 to pi 6. You know it, I know it, it's pi squared over 36. Yay, that's it, that's the answer. All right, I'm going to take this moment here at the end to talk about arc sine of 1/2. So I said sine of what is 1/2? Well, it's an angle, right? Sine of some angle theta is sine of some angle theta is 1/2. And if you remember your favorite summer camp, SOHCAHTOA, you'll know that 1/2 is opposite over hypotenuse because that is the SO in SOHCAHTOA. If you don't know what SOHCAHTOA is, you can email me. Okay, so opposite over hypotenuse. I get a right triangle, of course. Opposite is 1. There's my angle. Opposite side is 1. The hypotenuse is 2. And we should know then that the adjacent side or missing leg is going to be the square root of 3. Okay, so that's your basic setup. Nothing really calculus going on here. It's a right triangle, so you have pi halves in the corner. And now all you have to decide is where's the big angle, where's the little angle. And the big angle is going to be pi thirds, and the little angle is going to be pi sixth. Those are your options. If you're talking about sine, you get like pi fourths, pi sixth, pi thirds, or 0. You know, like we're not here to torture you, despite what you may think. So the opposite side you can see is smaller than pi thirds. Okay, so that means that the small side, the small angle is looking at the small side. Okay, this is like law of sines here. Small angles look at small sides. Big angles look at big sides, and vice versa. So this is the small angle, that means it's pi sixth. And guess what? The other angle would have been pi thirds. Wow, triangles are fun. Okay, enjoy. Goodbye.